Hey there, and we are back with computer tubes. In my previous video, I was basically sorting a bag of computer tubes like these two guys, the Epic Battle, IBM and Remington Rand Univac. And while I was reviewing the footage right before I uploaded last night, it came to me that maybe some people don't know what I mean when I say that a tube is computer rated. Why are some tubes called computer tubes and some aren't? Now, of course, with these guys, that's a 5Y3, nothing special. It's just like a 5Y3 in your guitar amp. There's nothing special about it other than the printing. But if we look at this 6463, it is indeed a special computer rated tube. Now, I mentioned that there was something called cathode poisoning, cathode interface problems, and such like that. And that's what I'm going to talk about, is what the issue is. Well, back in the early days, and actually this was more of a radar thing than a computer thing, is when they started to see some of these weird effects where if you put normal tubes in a digital environment where they're cut off for a while, they aren't conducting. They're kind of doing a zero, if you will, in the binary sense. Oftentimes they will not want to really wake up too fast. They get sluggish. The slang term was sleeping sickness, and it would make the circuits basically unreliable. You might have a flip-flop that sort of flops, if you will. And they found this amongst, early computers and also in the early days of radar. Well, not so early days, but the early-ish days of radar IFF sets. IFF is interrogation, friend or foe. Basically, it was a system devised in World War II where a radar could more or less interrogate a target like an aircraft with a pulse, a microwave pulse, and a special transponder radio on the aircraft would reply with a pulse that then would be sent back to the radar. And, well, if the things matched, the correct pulse was given back, well, you knew that, hey, that was a good guy, don't shoot him down. Well, in the late 40s, they started coming up with a digital version of that IFF system, and which is sort of still around today. If you hear about people squawking the IFF, and there's a 4-digit number, which turns out to be octal digits, mind you, it's the same thing that was used back in the extremely early 50s. And all these jet fighters and bombers back in the 50s had these little digital boxes with tubes. There was no computation happening. It would just spit out a digital code if it ever was interrogated. And let's see, it was 11 bits long, I think, because it wasn't a full 4 octal digits. The first digit was truncated a bit. In any case, a lot of so-called computer-rated tubes actually were made for radar IFF applications. And the computer people, IBM, Remington Rand, picked them up, said, hey, we can use these. And then, of course, in the early Whirlwind project, they also found kind of the same thing, what was going on with the just standard tubes, commercially available tubes, why these tubes were essentially failing. And so lots of work was put into it. And what they found was the cathodes were getting poisoned. And we'll make a little drawing here. Let's get you guys out of the way. Get my paper here. We're going to do sort of a top-down view. So let's make a heater there. Say that's the filament. This is the cathode. And then on the cathode, of course, we've got the secret sauce. And that's where the electrons come from, essentially. And of course, out here would be the grid, and then the edge of the paper would be more or less the plate. What was happening is when the tube was cut off for too long, some of the impurities in the metal would actually leach to the surface. And we'll do that in red. Turns out the impurity that was causing all the problem was, ironically, silicon. The silicon would kind of migrate to the surface of the cathode and form a compound with the barium. And the barium, of course, was from the getter, that shiny stuff that you see on the top there. That is, a lot of people think it's mercury. No, it's not mercury. It's barium. It's almost always barium. And it would form this compound that I've drawn in red here, which would sort of get in the way and impede the electron generation. If you don't have electrons, you don't work. So yeah, if the electron count would be reduced by these compounds forming on the surface of the cathode, and the tube would not work properly. And basically what would happen would be, oh, you can see a little bleed through, I'm sorry. In a circuit, in a normal circuit, here's your tube, and then the heater would be down there. And normally you'd have that go to ground. That interface layer on the cathode would essentially cause a bit of resistance and capacitance to get put into the circuit where you didn't want it to be. That would screw things up. It would essentially change the parameters that you're working with, the tube is working under. Wouldn't work properly. Your flip-flops, like I said, might not flop. So what they did to solve this problem, get rid of this, let's get you guys back in here, was they basically got rid of the silicon. If you don't have silicon in the metal of the cathode, well, then it can't create compounds, can it? So a lot of cathodes are made out of nickel, the actual metal underneath. They started using ultra high purity nickel, and the problem more or less went away. So when you had a tube like a 6463, it's pretty similar to other tubes. It's, I think, pretty similar to probably a 12BH7 or something like that. It's just that the cathode material is made out of a much purer metal. This solved the problem, and all of a sudden we have computer-rated tubes. They were, of course, a little more expensive, and but they were fairly similar to the commercial things. Now, I did get a comment, actually just got a comment like about 10 minutes ago or something. I'm going to murder your name, I'm sorry, Benas maybe? Asked if there was anything else special about the computer-rated tubes, if they were military spec or anything like that. Well, there were of course military spec computer-rated tubes, but they didn't have to be military spec. They sometimes had somewhat looser specs. Like, if you're in computer digital work, you don't really care about noise. With the twin triodes, you don't really care that much if they're nice and balanced, which is kind of annoying because a lot of the audiophiles kind of like these computer tubes. Well, they are twin triodes after all. But the things aren't made for audio. They tend to be kind of crummy audio tubes, but, well, no, let's not get into that argument. But yeah, there were a lot of specs that were loosened up from the commercial equivalents simply because you didn't have to you didn't have to worry about things like noise as much, or how well two sides of a twin triode are balanced. A lot of computer rated tubes are plug-in compatible, some are not. Like that 5915, where is it here? It is essentially very similar to a 6BE6 converter tube, but the one of the grids is not spec'd the same way. It is not tested the same way because you're not using it as a converter. You're using it as, well, another gating electrode, if you will. So it is not spec'd the same as the commercial equivalent. Yeah, most of the time a 5915 will work just fine, but may not work as well. So there we have it. That's what is meant by a computer-rated tube. It has to do with this cathode interface problem and basically impurities in the metal getting to the surface of the cathode and causing your circuit to change by, well, throwing in this resistor and capacitor that you didn't have before. So I hope that kind of clears up what computer rated means. Yes, I do, like you see here, I do hoard these computer rated tubes because you can't really use reliably, standard commercial tubes. They might work, they might not. They might not last as long, who knows. But hey, why not use the right thing? Certainly IBM and Remington Rand and Burroughs and all the people that made tube computers did quickly shift over to using these special tubes. And yes, reliability went way up. Yeah, it still wasn't great, but reliability went way up. And, well, life was better. Someday maybe I will make a video about tube reliability in computers because it wasn't nearly as bad as it's mythically made out to be. That'll be another video. Anyway, I hope this answered any questions concerning what is a computer-rated tube. Leave a like if you like the video. Leave a comment. Maybe subscribe. Share it around. And catch me on Twitter. Uniservo is the name. Mostly I tweet out when I make a video. Sometimes other foolishness too. And yes, subscribe. Okay, talk to you later. Bye-bye.